Okay, so now what we're going to do is we're going to talk about special cases. What happens when this occurs? And so we've got really two special situations, and then we've got special names for these situations. So the first thing we have is what happens when your lines do not intersect. And when your lines do not intersect, they're called parallel. And we've talked about that before. Parallel lines are going to have the same slope, and we call these systems inconsistent. They're inconsistent because there is going to be no solution to the system. And so again, these are parallel, and we can usually tell because when we look at the equation, we're going to see that they have the same slope when they're parallel. Now, we also have when two lines do intersect. So when they don't intersect, they're called inconsistent. When they do intersect, they're called consistent. Now we have two options for them intersecting. We have them intersecting at one point, and everything we've done so far is them intersecting at one point. So there's actually a solution, and the solution is the one point where they intersect, but that equation is also what we call independent. So one solution, or pretty much an answer, is going to be consistent and independent. But we also have if the lines intersect everywhere, which means that they are the same line. Then what we call it is dependent. And when it's dependent, our answer is infinitely many solutions. And we've seen equations where when we solve it, we get infinitely many solutions. And so this occurs so this would be consistent, meaning they intersect, and dependent means they intersect everywhere. And so when we were solving equations before, we would end up with things like our x's would disappear. And if we ended up with something like our x's would disappear and we have 5 equals 5, that means it's true all the time. No matter what variable I plug in, it's true, which means that it's many solutions or infinitely many solutions. Now, are consistent and independent, that's where we got an answer. So we've been doing those all along. And then when they're parallel, they have no solution. And when we work them out algebraically, that looks like something like 3 equals 7, which is not true. 3 does not equal 7, so that means this is a no solution. And so we have these special classifications available to us, and so it's a good idea to practice them because you never know when they may pop up on your AMP test, SAT, ACT, and they may ask, what type of system is it? Is it inconsistent, consistent, dependent, independent? So it's good to kind of know these names. So I recommend having flashcards to just kind of remind you. So if it pops up, you know what they're talking about. Okay, so we're going to talk about graphing a system and what is the true answer. So my first one, I have y equals x minus 1, so I start at negative 1. And then my slope is 1, so up 1 over 1. So nice little review of graphing systems. And then I'm going to go ahead and graph the second equation, which is not solved for. So I'm going to go ahead and I have x minus y equals negative 2. I'm going to solve for y, so I'm minus 1x on both sides. So now I have negative y equals negative 1x and minus 2. I divide everything by negative 1. So now I have y equals negative 1 divided by negative 1 is positive 1. Negative 2 divided by negative 1 is positive 2. So now I'm going to graph this by starting at 2. And then my slope is up 1 over 1. So up 1 over 1. And it doesn't look like they ever intersect. So let's take a look at it really quick. Are they truly parallel? Let's look at our slopes. Our slopes are the same, so they are truly parallel. So then, what is our solution? Well, there is no solution because they will never intersect. So then the question is how do we classify this? And this is classified as inconsistent, since it will never intersect. So now we're going to move to our next one. Maybe it'll intersect, maybe it won't, we don't know. Have to try it out, don't assume anything. I'm going to start at -1 on my y-axis, and then my slope is 2 over 1. So I'm going to go up 2 over 1, down 2 over 1, left 1. Okay, now for my next one, I have to do the same idea. I have to solve for my y, so 2x minus y equals -1. I move my x to the other side. So now I have -y equals -2x and -1. I divide by -1 on both sides. So that cancels and I get y equals +2x, +1. And they are not the same equation. So now I go ahead and start at +1, go up 2 over 1, up 2 over 1, up 2 over 1. And it looks like they might be parallel. So now we double check. 2 over 1, 2 over 1. We look good to go. So it looks like they are parallel. So there is no solution. And they are inconsistent. It is an inconsistent system. And that's it. Okay, solve the system by using the substitution method and then classify the system. So now we're back to the substitution method where we're looking for an x equals or y equals. And our first equation we have a y equals. So I'm going to circle my y's. And I'm going to highlight what y is equal to, so x minus 3. And I'm going to put that in that y spot right there. So now I'm going to go ahead and solve. So I rewrite this one. So x minus, and now I put in the x minus 3 equals 3. Now I have to distribute not the x, but the number in front of the parentheses. And this is really -1, so I'm multiplying in -1. So now I have x, -1 times x is -1x. -1 times 3 is +3. -1 times -3, so negative times negative is positive, equals 3. Now our x minus x will cancel out. So now I have 3 equals 3. Are they equal or are they not equal? Well, since they are equal, this is many solutions. Or infinitely many solutions. And then we classify this. So because they intersect, it is a consistent system. And then because it actually becomes the same line, it is dependent. They are dependent upon each other because they are the same. So now I'm going to look at my next one, and I have a y equals, so I'm going to circle my y's. And I'm going to highlight what y is equal to. So y is equal to -2x plus 5, and I'm going to put that in that y spot. So now I'm going to rewrite my system. So -3x plus 3, and I put the highlighted portion in the y. So -2x plus 5 equals 6. Now I'm going to distribute that 3. So now this becomes -3x plus 3 times -2 is -6x. 3 times 5 is 15 equals 6. So a -3x and a -6x becomes -9x plus 15 equals 6. I subtract 15 on both sides. So now I have negative 9x equals negative 9. I divide by negative 9, and x is equal to 1. So now that I have x, I plug back into my original, which was y equals negative 2x. So in the x spot, I'm going to put 1 plus 5. So y equals negative 2 times 1 is negative 2 plus 5. Negative 2 plus 5 is the same thing as 5 minus 2, which is 3. So my solution is 1, 3, because remember x comma y. And now I have to classify this. So these lines do intersect, which means they are consistent. And because they intersect at one point, not all points, this is called independent. Okay, let's try our elimination method. So same idea, using elimination. So in our first one, our x's don't have the same number of different signs, and our y's don't have the same number of different signs. So it's up to us. We can change our x's or we can change our y's. I'm probably going to go ahead and change the y. So I want to change 8 and 12 into the same number. I could times by 8 and I could times by 12, but that's going to give me really big numbers. So instead, I'm going to think of something smaller. Let's see, 8 and 16. Well, 12 doesn't go into 16. 24. 12 goes into 24. So I'm going to change both numbers into 24. So I'm going to times the top number by negative 2. So that'll change my y into a positive 24. I'm going to multiply the bottom one by positive 3. So that way I get a negative 24. So now I'm going to rewrite the system. So I multiply everything on top by negative 2, so negative 14x, positive 24y, equals positive 44. Then I multiply the whole bottom equation by 3. So 3 times 5x is 15x. 3 times negative 8y is negative 24y. And 3 times negative 14 is negative 30 plus 12, 42. Now I add my two equations together, and 15x minus 14x is 1x. 24y minus 24y becomes 0, cancels out or eliminates. 44 minus 42 is 2, so I get x equals 2. Now I plug that back in to one of my original equations, and so I'm going to go ahead and plug it into, I guess the bottom one. So 5 times my x minus 8 times y equals negative 14. 5 times 2, because my x is 2, so 5 times 2 is 10, minus 8y equals negative 14. I move my 10 by subtracting 10 on both sides. So now I'm left with a negative 8y equals negative 24. I divide by negative 8 on both sides, and y is equal to 3. And since now I have an answer, 2, 3, that means that my lines intersect. They intersect at one point, so it's consistent because they intersect. Because they intersect at one point, it is independent. Okay, on our next one, we've got negative 7x plus y equals negative 2 and negative 7x plus y equals 5. I can't add it together because neither my y's would cancel out or my x's. So I'm going to have to change one of them by multiplying by negative 1. So I'm going to multiply the top one by negative 1. So negative 1 times negative 7 gives me 7. Negative 1 times negative y, or negative 1 times y gives me negative 1y, equals negative 1 times 2 gives me 2. So now when I add together, my x's will cancel because that turns into 0. My y's cancel, because when I add them up it turns into 0, which leaves me with nothing on this side. Now on this side, 5 plus 2 gives me 7, and now I have 0 equals 7. My x's went away, my y's went away, and so now I have to decide, are they the same line or are they parallel? And since these are not equal, this is no solution, which means they are parallel. And if they are parallel, they're considered an inconsistent system because they do not intersect. Inconsistent. There we go. And so those are all of our special cases and naming our types of systems.